we're going to be talking about how a relatively new technology, single pair Ethernet, is taking flight as the application journey continues. So the agenda for today is really to start with what is single pair Ethernet, just to make sure that we have a good understanding of what that is and its value proposition. And then for context, we'll talk a little bit about the application journey it's gone through, because I think that really sets the stage for understanding how it can be used to deal with some of the challenges that the next generation of technologies that are going to fly. And then we'll talk a little bit about the specific challenges as far as connectivity and wiring along things that fly. I'm going to turn it over to Sasha, who's going to give you some insight into the ecosystem of development options to make your designs easy in adopting this technology. And then we'll close today talking a little bit about why Microchip can help you on this particular journey. So let's start with what is single pair Ethernet. So very simplistically, it's everything you know and love about the traditional Ethernet with the exception of the physical media, where historically you've used a two or more commonly a four pair twisted wires. Single pair Ethernet is just a single pair. And what this does at a system level is it reduces the overall cost, weight, and wiring complexity. Now, we're not giving up some of these advantages for performance. So what's happening today is a standard committee are continuing to push the capabilities of the physical copper connectivity to give you more and more performance as you go. So this is a technology that has a future and you can continue to invest in. Many folks are kind of curious as to how this trade-off could come about. And if you look at all the detailed specs across the different underlying Ethernet technologies, there are a lot of individual differences. But at a very simplistic level, what single pair Ethernet does is it trades off the cable reach for the number of wires. So for a certain number of systems, this can be very advantageous. The interesting thing is that this is being driven by the automotive industry. So there's a lot of financial gain to making sure that this continues to get invested in. And they've also found creative ways of delivering power over this unique technology. So if we drill in a little bit deeper, there's two different flavors of single pair Ethernet that can be used together to create the maximum system value. On the left-hand side, you see a more traditional Ethernet architecture, where, as I mentioned before, the only difference is a number of wires that are actually making the connections. And this is following the Ethernet capabilities in all different ways, including the ability to support time-sensitive networking, which is very critical for some of the next generation platforms. And on the right-hand side, you can see that the Standards Committee has embraced the value propositions of single pair Ethernet one step further. By removing the switch and allowing multiple sensors or actuators to daisy chain off a single pair of wires, this is further reducing the total amount of wire, weight, and complexity, and therefore costs in the system. Again, these two technologies can be used together in tandem to solve some of your system problems. I mentioned power delivery. So power over Ethernet has been around for a long time, and single pair Ethernet does solve the challenges through different technical means, but it still gives you the ability to utilize this capability. A good example of why this matters is, think of a camera. You've got an opportunity here to power that and then have your actual data come back over the single pair of wires. But what if you could do everything with just one pair of wires? Again, this is really focusing on the value proposition of reducing the overall amount of wiring. So with this background on what is single pair Ethernet, I'm going to kind of turn to talk a little bit about the application journey so you can kind of get a sense as to how this has come about and why it will continue to be a technology that people are going to invest in. So let's step back and think about what happened through the factory automation efforts that are out there. So really what had happened is everybody was looking to gain additional productivity through the use of a large number of sensors and actuators. But the challenge was that as everyone strove to do the best possible job of creating that productivity at an individual machine level, there was a lot of interoperability challenges that were passed on to their end customers. Just imagine if you had a number of different products that were all adopting these various technologies. So no one of these protocols were fundamentally better than the other, but they all had unique values. So hence you have a very complicated ecosystem. And that stayed about for some time. And you can see here on the list, there was even an EtherCAT, which was an optimized version of Ethernet, but it had a lot of unique interoperability challenges. So this kind of stayed true for a while. But then what happened is, as Ethernet evolved to be able to become deterministic, it changed the landscape. Now what you had, as opposed to all the legacy different protocols, you now had a single protocol that allowed you to create networks, stacks, and software that were unique. You had the physical layer that could be changed to different flavors, including single pair Ethernet, but you all lived within that Ethernet ecosystem, if you will. So this really changed the way everyone wanted to go to market, and Ethernet quickly took over that factory automation. And it played out in a way similar to this here, where on the right-hand side, you had the Ethernet capabilities that would connect a number of different machines together. But now with single pair Ethernet, it allowed you on the left-hand side to go all the way down through the entire signal chain to individual valves and actuators and stay within that ecosystem. So this is really the basis for many of the factory automation initiatives today. We can take this learning from factory automation, apply it to different architectures, if you will. So here's an example of a solar inverter where it's tied together with a protocol that's RS-485. And it's done very effectively and efficiently at a base level. But if we look at the standards themselves and how they compare, the single pair Ethernet is very similar as far as a lot of the capabilities, but it brings additional value. First of all, it removes the gateway, which simplifies the system. It also gives you the ability to add in different security capabilities and has a benefit of a much smaller connector size. So if we go back and look at this same architecture here using single pair Ethernet, you see that the gateway is removed, reducing cost and complexity. You can even reuse some of the existing wiring if in a particular application if you wanted. And now you've got an all Ethernet architecture throughout the entire flow. So this is much more effective for everybody. I mentioned earlier the automotive industry was a big driver. And let's drill into a little bit more as to why that is. Think about your experience today in a car. There's so many systems, and they're broken into individual zones. And you can see here just on an individual door as a zone, you've got a lot of different controls. You've got your windows, your mirrors, your speakers, lock, you've got lighting, all kinds of things that you're interfacing with. Just imagine at a system level trying to get all these unique systems to work together, if you will. So you can see how single pair Ethernet could bring some real value to this. But a car is just not one door. It's built out of a lot of different other subsystems, if you will. And some of those have a lot more complexities and deal with a lot of sensor fusion challenges, if you will, to start to automate the driving experience. So if we tie this together and look at an automobile today, you've got a number of different zones. And you can see where, in addition to just moving the data, that there are additional challenges here, if you will, as far as security and safety. And you think of the value proposition of Ethernet in general and single pair Ethernet that we've talked about here, and having the T1S to support some of the individual controls and sensors, and the T1 to bring this together to a more centralized control to deal with the sensor fusion. You can really see how this is coming together and is a win for the automotive community as a general. We can look at other application examples. Here's one for building automation. Again, we probably overlook some of the complexities of there, but on a local basis, there's a lot of connectivity needs, and then that gets tied together at a much larger level. So you can see single pair Ethernet would really be great for the local connectivity and staying within that Ethernet ecosystem, especially for buildings that may have already been wired. All of this ties together very effectively. So if we scale back and look at the journey as a whole, we started with a lot of the factory automation and some of the industrial spaces, and we've continued to move forward, and automotive is the most recent adopter and driver of single pair Ethernet. But the next wave is starting to come here, and that's things that are flying. So historically, we've got commercial platforms for domestic travel, international travel, and so on, and that's going through an evolution of more electric aircraft trying to drive fuel economy. We've also got a drone market that's evolving to just consumer to a lot of different applications here, whether it be for agriculture or package delivery. And then we've also got new classes of vehicles like flying taxis that are coming together. So this is the next application driver for single pair Ethernet. So let's talk a little bit now about some of the challenges that come about dealing with some of the communication wiring and things that fly. So we all get on our airliners and we probably think nothing about the fact that there's a lot of wiring that connects all this together. So a Boeing 747, for example, has over 140 miles of wiring, and that relates to over 3,000 pounds. So you can see if we can do anything to improve this, this directly goes to the airline's bottom line. And if we look at other types of fly-by-wire challenges out there, whether it be helicopters or other forms of planes, they're all in that same mode where the wiring itself is just something that's going to be a challenge. So single pair Ethernet being able to reduce that weight and the complexity has a direct value proposition. But we're really at a time when innovation is starting to happen in the aviation industry in general, right? We're not just dealing with your traditional set of Airbus and Boeing platforms. We're now dealing with a whole new class of flying vehicles, if you will. And all of these are being challenged, if you will, to deal with different types of control planes, different types of propulsion, and new different safety challenges. And the fact that some of these are designed to be autonomous, there's a lot more complexity that goes into these. So we now have a number of different factors that are going into a market that's going through very strong innovation. So what does this mean? Well, this is only going to take the amount of wiring and it's going to increase it. So these systems are getting more and more complex, which means more control planes and more sensors that have to be tied together. And the types of sensors are also going to be combined in ways to deal with intelligent decision making, if you will. So this is something that's going to take the traditional wiring challenges and they're going to go up dramatically. And if you tie this back together with the value proposition of single pair Ethernet, you'll see that they're very nicely aligned. So if you can make a plane or something that flies lighter, you're going to get longer flying times. So the fact that we can reduce the amount of wiring has a direct correlation. Same with the sensor fusion. You've got a lot of information that has to be tied together. I mentioned time-sensitive networking is supporting on this, so you have the ability to deal with a lot of those complexities, if you will. And upgradability is another important factor. So Ethernet has really been the standard for a long time. Investing in subsystems that support this protocol is only going to make it easier and easier to expand the market. So with this, I'd like to pass it over to Sasha to talk to you a little bit about how you can take this learning and start to apply it to some of your next designs. Sasha?
Thanks, Chuck. I'm going to spend a little bit of time talking about how the Microchip ecosystem enables you to quickly and seamlessly integrate single pair Ethernet into your new and existing projects and designs. The Microchip's SPE ecosystem is broad and it covers a whole gamut of solutions. We offer everything from Ethernet PHYs, Ethernet controllers, all the way up to high-end managed network switches to enable single pair Ethernet no matter what application or project you might be working on. Easy-to-use hardware is essential for rapid prototyping of solutions, and Microchip offers a whole slew of evaluation boards to help you on this journey. One of my favorites is the one in the top left here, the MAC-PHY module. On one end, you have SPI, and on the other end, you have a T1S twisted pair. You simply wire the SPI to your host controller, send it a MAC address and an IP address, and you're good to go. You're on the T1S network. Pretty easy to use. Another popular board is the one in the bottom right. It's a USB-A to T1S network interface adapter. plug this into a Linux or Windows-based PC, install Microchip's provided drivers, and it'll enumerate just like any other network interface card on your system. It's great for prototyping and debugging, and we'll touch on this a little bit later. If you already have a design that's using standard two or four pair Ethernet, you can use the board in the bottom left. This board allows you to plug in an RJ45 jack on one end, and then you have T1 on the other. It's great for testing throughput and making sure that your system will play nicely with T1, even play nicely with T1. Open source software is the key to getting hardware up and running quickly. Microchip offers mainline Linux drivers, free RTOS support, bare metal drivers through MPLAB Harmony. We have support for Zephyr, and there's also Windows drivers available. Where T1 and T1S really shines is when it comes to debugging. You can use off-the-shelf vetted tools such as Wireshark, Ping, Traceroute, IPIFconfig, Netstat, and many others. I've been tasked in the past with integrating a custom tracking solution into a school bus type system. And this was a CAN bus where I had to identify all of the custom nodes on the bus and use third-party proprietary tools to debug and figure out what was going on. And this was quite a big hassle. If you imagine that bus having a T1S solution on it, it would have been much, much easier for me. I would have been able to grab our USB-A to T1S adapter, connect my Linux computer to that bus, and start identifying using the common tools. I would have been able to set up filters for Wireshark. I would have been able to write scripts to ping all the different nodes on the bus, and debugging would have been a lot easier. I'm sure we've all worked with proprietary protocols before, and we know how much of a hassle it is. Our Curiosity development boards offer a modular plug-and-play platform for rapid prototyping. The Curiosity platform offers hundreds of nanoboards that can be combined with our T1 and T1S solutions to allow you flexibility to create designs for nearly every use case. As an example, you can grab an 18 mega C nano board and a T1S click stepper board and put it together to maybe have a stepper motor controller on a T1S bus. And now imagine grabbing an IMU clickboard, connecting that to, and now you have inertial data on that same bus as well. The possibilities are really endless. Our fine Mac-PHY solutions can be paired with a variety of Microchip products. We have everything from 8-bit, 16-bit, and 32-bit platforms, along with Linux-based platforms. But remember that T1 and T1S are just physical layer implementations. So as long as your host has a Mac or an Ethernet Mac on there, you're easily able to connect one of our PHYs to it and have T1 and T1S enabled on that platform. Whatever your go-to platform is, Microchip has an SPE solution to support it. There's an Arduino-based SPE Shield available, along with a Raspberry Pi Pico board that's also SPE enabled. If you're familiar with or already using those platforms on your current project, it's a great place to start. Bean.io is another fully integrated solution based on the Raspberry Pi platform. It enables you to connect sensors and have them communicate directly with the cloud. It's fully open source and compatible with Arduino as well. Mixed network managed switch boards are also available and are a great way to start testing larger networks. This is an example of one of those boards where we offer 5 T1 base ports, 1 T1S port, and a gigabit uplink. With this board, you can easily connect 5 different actuators or cameras to the T1 ports, a chain of sensors. Remember that T1S is daisy chain, so you can have 7 or 8 sensors on that one bus, and then a gigabit uplink to your host. Your host can then manage that port and make sure that all the traffic is flowing correctly and that you have the bandwidth you desire. Another great way to use this is to be able to test interoperability between multiple different vendors in your own system, or potentially even have multiple nodes from your own system to make sure that they function when they're in a larger network. This is a larger example of the previous board where we added a gigabit cascade switch to it to offer more connectivity. This particular board has 9 T1 ports, 3 T1S chains, and a gigabit uplink, offering much larger connectivity for those applications that need more nodes. we're all familiar with the RJ45 style connectors. We've used them in the past. So you might be wondering, well, what about T1S? Luckily, the automotive and industrial spaces have put together a slew of different connector solutions that are available and easy to integrate. These solutions are rugged, they're shock resistant, and also water resistant. And there's definitely a connector for any solution you might be putting together. However, what we usually do, and on our bench, is we just take two wires, twist them together, strip the ends, and screw them into our screw terminals on our evaluation boards. It's as easy as that. And for prototyping and getting things up and running, no need to crimp any wires. Microchip offers a large slew of resources for T1S. Our T1S landing page and Ethernet single pair landing pages are available through the links here. And we offer a great class at Microchip University for single pair Ethernet. This class covers the basics of single pair Ethernet, board and system design considerations, setting up a basic network, and an overview of the ecosystem. In terms of Microchip University, there's also a whole lot of other classes available, and I recommend you check it out and sign up if you're interested. We offer classes that include embedded Linux, motor control, analog and sensor design, and many, many others. These classes are online, they're easy to digest in small chunks, and you can take them at whenever you have some free time. And with that, I'll pass it back to Chuck.
Thank you very much, Sasha. So we're going to try to bring it home here today, talk a little bit about why Microchip and single pair Ethernet on things that fly. So if you step back and look at it, Microchip is a very broad-based Ethernet provider. We have a number of different products that we haven't talked today, spanning from the highest performance switches down to all different types of PHYs. We've actually even got power over Ethernet, which was a technology that Microchip invented. And Sasha gave us tremendous insight to the ability to adapt these technologies by utilizing a number of different internal and third-party boards, as well as leveraging the ecosystem of capabilities that have been built around Ethernet, and brought a little bit of focus on the debug sides of things, which is often an afterthought. So really, from our perspective, Microchip has a lot of value, and that includes folks like Sasha that are on our team to help individual companies move forward with this technology. So a couple other things just to keep in mind as you're going through some of your system level challenges is, in addition to having a portfolio of traditional PHYs for single pair Ethernet, we've actually done something unique, and we've integrated together a PHY MAC into a single part. So if you think of the value proposition around single pair Ethernet of decreasing complexity and weight and cost, you can see how potentially having this option together is helpful as you've put together your complete system. We've also done some things which are really revolutionary here as far as T1S here. This IEEE specifications are set up to support 8 nodes and 25 meters. And versus having just a single sensor actuator, this is already a huge system level value proposition. But with our technology that we've engineered and put together a demonstration vehicle on, you can see that we can go from 8 to 50 different nodes that are supported, and from 25 to 100 meters of cable. And if you think about the reality and some of the flying platforms, if you will, those additional nodes and cable length could really be invaluable in putting together your system. So, and this is something where we're not resting on our laurels. We continue to innovate and bring new technologies to market. This is an example of a recent press release where we've added some additional T1 PHYs to our portfolio of solution, and we're going to continue to do so. And we're also making sure that we fully integrate some of the higher level capabilities around the profiles for TSN. So this is something that really allows you to add much more complexity to some of the sensor fusion challenges, if you will. And we're bringing these value propositions to bear while keeping an eye on some of the traditional values. You can see here highlighted, we're doing this in a very power efficient way. So you get to add the capabilities without that power tax. And we're also leveraging packaging to continue to make sure that the weight value proposition shines through. And then the couple of development platforms that Sasha had shown in his presentation are tied to some underlying switch technologies that we have. Here is a fully integrated switch that supports TSN and a bunch of features that go with that, including some of the functional safety capabilities, if you will. And then we also have a cost optimized variation of this to drive some of the more simplistic requirements or some of the zones, if you will. If you think back to that automotive example, same things would apply to things that fly, where you might have individual zones that you want to try to manage. And if we put all of this together, hopefully this gives you insight as to what single pair Ethernet is and why it's been valuable to other industries and now to some of the challenges that are going to be happening with the innovation that's happening in platforms that are flying. And the fact that we support, a broad range of technologies, including both the T1 and T1S PHYs and switches, have an existing portfolio of development platforms, boards, debug tools, software, and so on, as well as the expertise to continue to innovate here. That really is a strong value proposition for Microchip as your partner as you go down this journey. And we've also illustrated a couple of individual silicon level features here on the T1 side, having power in the smallest package, and on the T1S being able to exceed that industry specification to allow you to supersize some of the system challenges, you will, and also having the integrated Mac PHY. So thank you very much for your time and attendance today, and we look forward to helping you on your journey of using single pair Ethernet in the next generation of flying platforms.
For our first question for Chuck, what is the version of PoE for single pair Ethernet?
Okay, so as I mentioned, Microchip does have a strong history, actually the inventor of power over Ethernet. That's its own, tree in the ecosystem around, Ethernet, if you will. So for single pair Ethernet, there is the ability to support power delivery, and that's referenced in the PODL Poodle support earlier. And, that's something that's available using a number of our products and some of the available boards. So it's technically a different physical connectivity and a different set of specifications, but the idea of serving the same application needs can be done with single pair Ethernet.
Awesome, thank you. And how is building with single pair Ethernet really different from traditional Ethernet?
So a couple of factors here. So first, as I mentioned, there are some nuances in the physical layer. So it is fundamentally different on how it connects. But then from all the other layers, Mac on up, it is the same as traditional Ethernet. The other value proposition it does bring is, as opposed to a traditional point-to-point concept within Ethernet, you can do kind of a daisy chain concept where along the way you can have a number of nodes hanging off of that. So differences at the physical layer and also differences in the topology and therefore how you can solve some of your system level solutions. It gets rid of the intermediate gateways, if you will, that can simplify the system, as I mentioned earlier.
Great. And what is the future of single pair Ethernet as you see it, as Microchip sees it?
Yeah, so again, this is an industry body, if you will, a set of standards, and Ethernet's history has been very strong and in gobbling up some of the more niche protocols. We see no reason for this not to continue. And as I mentioned before, the adoption of single pair Ethernet is only growing. And so to me, there's a very strong future. And I also referenced earlier the fact that we're going to continue to follow the standards and make investments in higher performance versions from a data throughput point of view. So I think both from the risk and longevity, it's very solid, as well from a scalability for bandwidth that's already intact, and a lot of the standards up to 25 gig are already mostly in place at this point.
Thank you. And we did see there was a question in the chat. And just so you know, we have shared a couple links there. If anyone has any additional questions, please feel free to add it to our Q&A.
Thank you, and thank everyone for their time. If there aren't any other questions.
Chuck, did you also check the Q&A just to see if we had any other questions come in?
No, let me do that. Sorry.
No, you're good.
So the question is in regards to some of the drivers that are available. So I honestly am not an expert in some of the upper protocol levels here, but we are fully compliant with all of the different Ethernet standards and capabilities. So the delivery for the appropriate drivers should all be intact there. And we do offer the Mac support for both our FPGAs and our processor offering. So if there are other specific questions that we can help with, maybe you can connect us and we can get some of our apps folks to go a little bit deeper in any of the nuances there.
Sounds great. Sounds great to me. Thank you, everyone. Just big thank you to Chuck and Sasha for a great webinar about single pair Ethernet.
Thank you. Have a great day, everyone.